All right, so 5.1 composite functions. Here we go. Our first objective is to be able to form a composite function, okay? Here's our real world example, because you guys are constantly asked, when is this going to be used? When blah, 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 right? This is an example of a composite function. Most of our world runs on composite functions. It's not just one function that makes things happen. It's multiple functions working together to make something happen, okay? So, multiple functions, one function inside of another function to solve a problem, pretty much. All right, so for example, suppose that an oil tanker is leaking oil and we want to be able to determine the area of the circular oil patch around the ship, okay? This is so that we can prevent it from expanding, right? It is determined that the oil is leaking from the tanker in such a way that the radius of the circular oil patch around the ship is increasing at a rate of 3 feet per minute, okay? So in order for me to try to contain this spillage, right, I have to figure out the rate that is happening and then figure out what area it's going to encompass. Does that make sense? So the first thing I do, that's the inside of your composite function. So the first thing we did here was we're going to identify the rate. Once we identify the rate, then it's going to help us determine the area that is going to reach. And so put it together, and now I have one formula that as a scientist who's working with this oil leak, I can now quickly calculate to figure out, all right, at this time, we should be here. At this time, we should be here in order to try to clean up or create a barrier so it doesn't keep expanding. Does that make sense? Okay. And so this is your real example as to our unit. So I'm going to be doing my best to try to give you those real world examples as you're starting something, because I know I get the, when is this going to be used? Well, here's a real world example of where composition really comes into play. Okay. All right. Oh, how did you know? Here we go. Definition. So given two functions, f and g, the composite function is denoted as f composed with g. Okay. Do you remember kind of seeing quote unquote fog last year? Yep. Okay. F composed with g. And it's defined by saying, if I'm saying f is composed of g of x, that means I'm substituting in g of x into f. Okay. The domain of f composed with g is a set of all real numbers, x, and the domain of g such that g of x exists. Now, remember, it can also be the other way around. So it may not always be f composed of g. It also can be g composed with f, right? Which means that I'm taking g and substituting in f of x into that function. Okay, back in my day in school, I called this fog and goth. I did? My bad. You know what I meant. Okay, so this is just saying that it could be both, fog and goth. All right, so we're going to first start talking about what we did in Algebra 2. So we're going to go through examples of what we did in Algebra 2, and then we're going to transition into what's expected in pre-calc, okay? As of last year. This year, they did all of it. You just had blanks to fill.
Sorry, it was the words are out of order, so it threw me off.
It threw me off too. I'm always thrown off.
The main thing is this. That's the main thing. Okay, huh? Do not need to write this. This is a visual model of how you can see what's happening. So what happens is you're taking the x values and you're plugging them into for the range from one function to the other and going back and forth. The other thing is, back in Algebra 1, you guys worked with one function machine. Now you're working with two function machine. Okay, so that's the difference, right, Marshall? Okay, all right. First, we're going to start off with Algebra 2, evaluating a composite function. So in Algebra 2, we talked about evaluating. In your box A, you're going to write f composed with g at 1 or of 1. In your box A, you're going to write this. Okay, does this look vaguely familiar?
No.
Okay, when we did this last year, you start from the inside, then you substitute, and then you evaluate, okay? Same thing is gonna happen. Our inside is g of 1. So we're gonna find g of 1 first. G of 1 means I'm taking the function g of x equals 4x cubed plus 1, and I'm substituting 1 in for x. So we have 4 times 1 to the third plus 1. That gives me 5. After I take this, after I get the inside, I'm then going to substitute it back in to the outside function. And what is my outside function? F. So now we're going to find f of 5. F of 5 is saying is I'm going to use function f, and everywhere there's an x in function f, I'm going to plug in 5. So we have 2 substitute in 5 squared plus 3. That gives me 2 times 25 plus 3. That gives me 50 plus 3, which is 53. So after evaluating, I get f composed with g at 1 equals 53.
No?
Do we kind of remember doing this last year?
Oh.
Or a couple? No? Yeah? Yes? A little bit? Okay, I'm going to put up B, so I'm going to stop talking. And I'm going to put up B, and I want you to do B on your own. Got it? And then we're going to come back together. Is that okay?
Okay.
All right, so here's yours. Oh. All right, so for B, you're writing down G composed with F at 1 or up 1. All right, here we go. So we have F of 1. So our inside is F of 1. And we have 2 1 squared plus 3. What did that give us? That gave us 5. Because 1 times 1 is 1. And 1 times 2 is 2. And 2 plus 3 is 5. All right.
I ignored all of that.
Where did you get 8, though?
It's it's 4 plus 3 is
Okay, don't do that. It is. Here we go. We're on G. So now that we have F, we're going to plug it in and find G. So we're going to have G of 5, which equals 4 times 5 to the third plus 1, which equals 4 times 125 plus 1, which equals 500 plus 1, which is 501.
You know, my heart was in the right place.
Yes.
Okay.
Okay.
That was a little funky.
All right. The next 2 examples, as you can see here, is you're gonna plug it back into itself. So you're gonna evaluate and then plug it back into itself.
No, thank you.
Okay, because you can put a function inside of itself. All right, so that's what C and D are gonna be examples of. So here's your C. If you're a person who is still a little off, raise your hand. I will come work it with you.
Are we gonna do it by ourselves?
Yes. All right, here we go. So C, really quick. So on C, the inside was F of -2. What did we get when we evaluated -2? 11. And then after we got the 11, what do we need to do? Plug it back into F again. And then what did we get for F11? 245 is our final answer. Okay,
I did not do that at first.
but you got it again?
I got it the second.
There we go. All right.
No.
All right, let's do D. So D, this time it was G composed of G at -1, right?
Yeah.
So again, our inside this time is G of -1. So what do we get for G of -1?
-3.
-3. And after we got -3, what do we do to it?
Put it back in.
Put it back in. And what do we get? -107 as our final answer. Okay. We cannot. This is algebra 2. Okay.
Can we go back to algebra 2? Wait, so we're going-
All right,
Easy.
so this is the composition and evaluating composition that we did with algebra 2, okay? All right, I had to get that refresher going so you can see where we're going, so that this was pre-required knowledge,
This was serious.
okay? This is pre-required knowledge.
So we weren't even like supposed to learn.
You were
We
supposed to
only
learn it,
supposed to know that.
yes. Yes. All right, now we're going to move into the pre-cal part, which is to find the domain of a composite function. So to actually complete a to actually combine two functions together to make one function. Okay, that's our goal now. So our goal is to take the functions and combine them to make a new function and to define the attributes of that new function. All right, I did not. I told you over and over that it was algebra 2. All right, so here we go. Finding a composite function and its domain. The first thing we're gonna do is read it and then start and go from there. All right, so it says f of x equals 2x squared minus x plus 4, and g of x equals 4x plus 1. Are those two functions that we have dealt with before?
Yeah.
Yes, f of x is a quadratic and g of x is a linear. Agreed? Okay.
Good.
No. All right. So the first thing it wants to do is 2a, we're going to find f composed of g and see what new function they create by doing this. So instead of just plugging in a number for x, we're plugging in an entire function for x. Okay. So it says here f composed of g of x, which means we're taking whatever g of x is and we're plugging it into f. Okay. When we do that, we're going to FOIL, distribute, combine like terms. FOIL, distribute, combine like terms. Okay. All right. So this is, what is g of x? G of x is 4x plus 1. So everywhere there's an x and f of x, I'm going to put 4x plus 1. So I have two parentheses, 4x plus 1 squared minus 4x plus 1 plus 4. That's because everywhere that there was an x, it became 4x plus 1. Do we see that?
Unfortunately.
Everywhere that there's an x, because I'm not just plugging a number in, I'm plugging a whole function in the place of x. Okay. After I do that, we're going to FOIL, distribute, combine like terms. FOIL, distribute, combine like terms. Why do I have to FOIL?
Because the 4x plus 1 is squared.
The 4x plus 1 is squared. So this right here says that this means that I actually have 2 times 4x plus 1 times 4x plus 1 minus 4x plus 1 plus 4. So I'm going to FOIL, distribute, and combine like terms. Okay, FOIL is just a way of saying I'm doing multiple distribution at one time. Does that make sense? All right, so let's start our FOIL. So I'm not going to touch the 2 yet. I have 4x times 4x is 16x squared. We have 4x times 1, 4x. We have 1 times 4x. And we have 1 times 1 is 1. We're going to distribute the negative. So we have a negative times 4x is. We have a negative times 1 is negative 1.
Why am I the only one talking? It's so hard.
I don't know, but good job. Okay. All right. Am I complete? Are all my parentheses gone yet? No. So that means I have multiple distribution to go, right? So I'm going to distribute the 2. 2 times 16 is?
32.
2 times 4 is? 8. 2 times 4 is? 8. And 2 times 1 is? 2. Bringing down what I have. Are there any more parentheses?
No.
No. So I have FOIL, distribute. Now I'm going to combine like terms. So I'm going to combine like terms. Does x squared have anything else besides 32? No. So I'm gonna write it up here, 32x squared. Okay, I have 8x, 8x, and negative 4x. So 8 plus 8 is 16. 16 minus 4, 12.
I was right.
Okay, then I have 2, negative 1, and 4. 2 minus 1 is 1 plus 4 is 5. So this is my new composed function. And what type of function did I create? So you're going to state its parent and then state the domain. What is the parent function? A quadratic. It's a quadratic. So therefore, what is the domain of this function? All real numbers from negative infinity to positive infinity. And that's how you complete it. That's it. You find the composite, you describe its parent, and then state the domain.
Well, let's do that with U of F now.
Now you're going to do the G composed of F now. Why, yes, you are.
When?
Now,
On what space?
What's there?
the next one below.
Oh. I thought that was a totally different one.
Yeah, it's a whole problem.
That was a whole. Thank
All
you
right.
for providing that.
Yes.
That was a lot.
All right. Now it's your turn. Okay. So you're going to do B, but this time we're doing G composed of F, right? So that means we're taking F of X and we're plugging it into G. So G composed of 2x squared minus x plus 4. I would like to say that we did the harder one together, or the one that requires a little more work together. Not necessarily harder, but I'm going to let you do this. And again, as we're working, if you need help, let me know. Here we go. So we have G composed of 2x squared minus x plus 4. That means that we're taking our entire f of x and plugging it in for x of g of x, right? So that gives me 4 parentheses 2x squared minus x plus 4 plus 1.
That's what I got.
Okay. After I substitute in, I FOIL, distribute, combine like terms, right? FOIL, distribute, combine. So I'm going to distribute 4, and that's going to give me 8x squared minus 4x plus 16 plus 1. My only like terms are 16 and 1. So we have 8x squared minus 4x plus 17. What is my parent function? A quadratic. So my domain is what? All real numbers. Negative infinity to positive infinity. Okay? Huh? Write an 8? Why? It's right there. Girl. All right. Yes? Okay. Now, here's another one. This time we have 2 rational functions. Do we see that? Yes. So we're going to have a function and a function, but also a fraction within a fraction.
Wait, no, when you give us today, are you asking us for the parent function and the domain?
That's how you state the domain. You tell me the PF, and then you state the domain. Your job, eventually you don't have to tell me the PF, but you still need to know that your PF is based off of properties of your domain. Okay? So like rationals, their domain depends on their denominator, right?
Yeah.
Yes.
And so therefore, when I combine this, if I have a rational, I can look at my denominator to determine my domain. Okay. All right. So we're doing G composed of F. That means I'm taking F of X and plugging it in for X. Do we see that? Yes. Okay. So I have 3 over, but instead of just having X, it's going to be 2 over X plus 1 minus 5. I told you were going to have a fraction within a fraction. Welcome to pre-AB. I warned you we were going to put a fraction in a fraction.
It's too late to leave.
Yes. Y'all are, all right. So, and what happens here is that we have to evaluate, we have to get our denominator down to 1 fraction. Okay. We're going to get our denominator down to 1 fraction. What I like to call this is chopsticks in a bowl. It's going to be the fastest way for us to do it. Okay. So Pretend that I have like a giant magnifying glass and I'm zooming in. I'm gonna do the work on a separate, like in a separate little space. So we have 2 over x plus 1 minus 5 over 1. Why did I put 5 over 1?
To help yourself.
To help myself, because the 1 is not gonna change its value. Exactly.
Well, the white put a 5.
Because it was minus 5.
Oh, God.
It was, the 5 was already there. I just put it over 1. All right. So, we need to find, we need to have a common denominator, right? So the denominator here is x plus 1. So the denominator here also needs to be what? X plus 1. So if I multiply this denominator by x plus 1, what do I have to do to its numerator?
X plus 1.
I also have to multiply it by x plus 1. Okay, that's how you turn it into a common denominator. Because in order to add fractions, they have to have the same denominator, correct? So now I can write this as 1. I have 2 minus 5 times x plus 1 all over x plus 1. So now it's almost one complete fraction. Okay, what's left to simplify this fraction?
Combine like terms.
I'm going to distribute and combine like terms, right? So I distribute
Yeah.
and I get 2 minus 5x minus 5, which comes out to be negative 5x minus 3. We just put the x plus 1 there, so we wouldn't want to cancel it out. And we can't because it's 2 binomials. It's a binomial, so you can't just cross it
Are we
out.
done now?
Wrong.
Huh?
Is he done now?
So this is now what I need in the denominator.
What about that divided? What about that 3?
We're coming back.
Oh.
I just said this was our side work.
Awesome.
So now we have 3 over negative 5x minus 3 over x plus 1.
Only we had the other one. Keep changing.
What? How do you divide fractions?
Keep changing.
You keep, change, flip. You multiply by the reciprocal. We do not divide fractions. We multiply by the reciprocal. So this becomes 3 over 1 times x plus 1 over negative 5x minus 3. It's bringing me joy.
We can tell.
I can't get the smile off my face.
Thank you, Samuel. Thank you.
You should get that checked out.
All right. So now my final new function is multiplying these together to become 1. And so when I multiply them together, become 1. What is 3 times x?
Yeah.
3x. What's 3 times 1?
3.
And then my denominator, 1 times anything is going to be its self. So here is my new function.
That's stupid.
It's not.
So much.
There's my new function.
It looks more complicated than the beginning.
Looks like it's. No.
So my new function, it created a what? A rational. And how is the domain of a rational determined?
Denominator.
The denominator, what your denominator cannot equal is 0. Okay, so I add 3 and divide by negative 5. So x cannot equal what? Negative 3/5. That's my domain. And that's because it's a rational, and the domain of a rational depends on its denominator.
Why is it just like it's not easy?
Does not equal 0. That's so that you can remember that it's what x cannot equal. So when I say not equal to 0, so remember what can x not be. You can write x equals 0. I just write it in my
Do
mind.
we have to write this on our test?
Now on your test, you would write this. Domain is x cannot equal negative 3/5.
Okay,
That's something you do.
okay. Okay.
All right. This would be the hardest you would get.
Really?
Oh, are you?
Okay.
No, you said.
For algebra.
This would be the hardest. Okay.